In this short video, I am doing a supplemental exercise example for the lecture class General Physics 1. And today I just want to work through a little example about diet and exercise. The example begins with a couple of facts. The first fact is that a food calorie contains 4,200 joules. So each calorie of food is the same energy content as 4,200 joules. The second is that I found that on the website for Moe's Southwest Grill that their nachos are about 1,700 food calories. And that is give or take for whatever ingredients you decide to put on those nachos. But I thought, what would it take if you were to sit down and eat a meal consisting of nachos from Moe's? How much energy would you need to burn off in joules to get rid of the effects of that meal? And for that matter, let's say that you decide to do a simple exercise like a deadlift. How many times would you need to rep your deadlift before you get rid of this much energy from your meal at Moe's? So the first step is to convert this food calories into joules, or in other words, to convert the energy content of Moe's nachos into SI units, which we're more familiar with working with. So energy from the nachos is going to be 1,700 calories times 4,200 joules per food calorie. And so when I do that calculation, I come up with a total energy for the nachos of a little over 7 million joules. In fact, 7,140,000 joules contained in those nachos. So maybe you sit down, you have a meal consisting of these nachos, you decide you're going to go to the gym and try to work out and burn off this meal. And probably you really go to the gym and do a variety of different exercises. Maybe you don't even go to the gym, maybe you try running, although I suppose around Troy, where there's no running paths or sidewalks by the roads, that might be a little bit suicidal. So let's stick with the gym. You go to the gym and you decide that you're going to do a deadlift. Now, how much work you get out of this workout at deadlifts depends, I guess, on how much weight you decide you're going to deadlift and how many times you're going to lift that weight, and then how high up off the ground you end up needing to lift it to complete your deadlift. So I find that in a deadlift you usually end up lifting from ground level to roughly waist level. So depending upon your height, a person who's maybe a little bit taller than I am, that might be about 1 meter. So we'll call that delta H equals 1 meter. And next we got to figure out how much weight we're going to lift. So I guess I'm going to assume that it's a man who's working out. He's eating his nachos, he's going to the gym, he decides he's going to do the deadlift. He's in okay shape, but he knows he needs to rep whatever this is, so he decides to go with a pretty heavy weight, but not so heavy that he can't rep it. I picked actually kind of a ridiculously heavy weight. Let's say he decides to do 200 pounds. So that's not an unreasonable amount to deadlift a couple times, but if you want to deadlift it, say 50 times or 100 times, this maybe is going to be a bit tiring. So let's see what happens. How many times do we have to deadlift this 200 pounds? By the way, 200 pounds is roughly 90 kilograms, so let's round this to 90 kilograms since we're going to be working in SI units. So how much energy does he burn each time that he lifts 90 kilograms up off the ground? So E for lift is going to be however much work he does against gravity. So that's going to be the mass he's lifting times the gravitational acceleration times the height that he lifts it. So we'll call it 90 kilograms times 9.8 meters per second squared times, let's say 1.0 meters, 1.00 meters. So how much energy does that come to? When I plug all these into my calculator, I end up getting approximately 884 joules per lift. Okay, well, let's say that he is going to lift this weight, and then instead of just dropping it, since he knows he's going to rep it, he lifts it, then he lowers it gently to the ground, then he lifts it, lowers it gently to the ground. So each up and down basically means we multiply this number by a factor of 2. One time because he's working against gravity going up, one time working against gravity going back down. Okay? Or in other words, he's still applying the 90 kilograms times 9.8 meters per second squared force as he's lowering the weight. It still takes some amount of muscle to lower that weight back down. And according to the Survey and Vuel textbook, muscles are about 25% efficient between the amount of energy they use and the amount of energy that they put out. So in order to muster this much energy for lifting, or in other words, to do this much work, muscles actually burn about 4 times this much energy. Okay, so that combined with the fact that we're going up and down means that for each lift that he does, each complete lift, he ends up burning through a total of E lift total of approximately 7,000 joules. Okay, so he's got 7,000 joules that he's burning off per lift or per rep. Maybe we'll call this E rep. Okay, and he's trying to get rid of 7,140,000 joules. So E nacho is 7,140,000 joule. So how many of these reps is he going to have to do before he's able to burn off all of those nachos that he ate at Moe's earlier in the day? Well, the total energy has to be equal to the energy that he took in from the nachos. That's the condition for burning off those nachos. Okay, so that's condition 1. Condition 2 is that total energy is going to be equal to the number of reps he does, number of times he lifts and lowers this dead weight, times the energy for 1 rep. So you can put these 2 equations together to solve how many reps he needs to do in order to burn off those nachos. So N is going to be E nachos over E rep. So 7,140,000 joules divided by 7,056 joules. So given that you have to do a unit number of reps, or a whole number of reps, I get that he needs to lift and lower this thing 1,012 times before he's burned off those nachos from Moe's. So I guess perhaps the moral of the story is, if you're trying to lose weight, don't treat yourself too much to the Moe's nachos, because it's going to take a lot of working out in order to get rid of that weight, or to get rid of the calories you took in from those nachos. So that's all for today, and hope you enjoyed this little presentation.